Hello everyone. So we created all of this bricks that move integer slots, but you can see that after they settle down, they go off and do their own physicsy thing, and it doesn't really make much sense in terms of a Tetris game. I'm sure there are lots of games you could do, but as you can tell, as far as Tetris goes, it doesn't bear much resemblance. So what we need to do is we need to make this thing behave more like Tetris. And the two basic options for that are we can either disable the physics entirely, or we can make it so that the physics work to our favor. Since I like the look of all of the bouncing and shifting and sliding, I'm going to keep that intact. And instead what we're going to do is we're going to make it so that the physics actively tries to sort this mess into a grid. And the way we're going to do that is we're going to edit the individual chunk scripts. So as you might remember, these Tetraminos, they have a block controller, but inside they've got all these individual Tetris chunks, and each of these has a chunk element script. We're going to start to use that now. It's empty at the moment, but I've added this function here, public void individualize, which is also empty, and I should have deleted it, but I didn't. Um, Basically, what happens is when the head brick decides that it has settled, then it's going to tell all of its children bricks where their preferred position is. So, and then it will delete itself and leave just the bricks. So we're gonna go and say public bool flying solo equals false, and public vector3 target pause. Down here in individualize, we say flying solo equals true, and transform.parent equals null, and target pause equals pause. But there's one more thing we need to do. These individual bricks don't have any physics objects attached to them. They have colliders, but no physics objects, so they won't bounce around or anything. So we need to add physics objects into them. And the way to do that is to do gameObject.add component, and then you do a rigid body, like so. This syntax is a little bit confusing if you're not real deep into the guts of C#, because this is a template class. It's a function that takes in a class as an argument. So we're not actually adding in an instantiated rigid body. We're telling the game object, hey, there's a component out there, it's called a rigid body, would you go and find one and make one for yourself, please? And that works because all of these classes here follow the exact same instantiation methods. So that means that Unity can instantiate it using some default methods that work fine. So I could pass it anything here. I could even pass it things like camera, but we're not going to. We're going to pass it rigid body. And it's going to come up with a default rigid body, but that's fine. What we do want to do is we want to edit it so that the rigid body doesn't have any of the slightly crazed parameters that it defaults to, which would allow things like spin. And well, let's go ahead and leave it like this for now. We'll do the spin. We'll edit the rigid body in a couple of minutes once we've seen what it does. Now over here on the block controller, when we do this on collision enter and we disable ourselves and all that stuff, what we actually want to do is we want to go through all of our chunk element kids, activate them, and then delete ourselves. So let's go ahead and do that. Get components in children. There it is. And you can see that we're using the same syntax again. We're just telling it, we're telling Unity, the Unity game object, we're saying there are classes like this somewhere in our kids. Could you please go get them for us? And I think that just returns. Just make sure. Yeah, that does return an array. Good. So then we walk through the array. Nope. And for each of these, we tell it to fly solo by giving it the command individualize. But what position do we want it to do? Well, we want it to be whatever our position is offset by whatever its position is from us. So and then we give it, well, I guess we can just pass it its position, but we're going to want to change this delta later. So for now, this is what we'll deal with, because we don't actually want it to be where it is. We're not going to use transform.position in the long run. We're going to be changing the position to be on an integer value, but for now this will work okay. We'll come back to it later. Let's put in a to-do. I should get used to putting in more comments on this tutorial code. Because I'm talking about it, I tend to have a really clear image in my mind of exactly what's going on, which can make it a little bit difficult to add comments just because you forget about it. But then we say this enable.false and so on. We don't actually want to do that anymore. We want to destroy ourselves. So we destroy and we list ourselves. Now, I think I've mentioned this in other tutorials, but we need to destroy game object. If we destroy this, then that gets rid of the block controller class on the game object, which isn't what we want to do, because that would still leave us with a game object. Instead, we want to destroy the game object. Normally that would take all of the blocks with it, but this separates the blocks from us, so they should survive. Let's go ahead and see how that works. Now I'm going to get myself up ahead of speed and up. Good. You can see how the Tetris chunks are now on their own. They're no longer part of a child. And you can see that they now work individually. And I'm sure you can make some fun games out of this if you wanted to. We're not going to play around with this, but if you wanted to make something that wasn't Tetris, you could use this same kind of method, cheese that falls apart sort of style. But you can see that we've got a lot of bricks tumbling, and that's what I was mentioning. We don't want to allow these individual pieces any more freedom than their parent. So we need to freeze. Here, I'll pause the game. We need to take these Tetris chunks, we need to freeze their rotation and their z-axis position. And the way we're going to do that is the same way that we did on the Tetris blocks, by simply marking these. But of course we don't have an inspector to mark them with. We have to do it in code. So the way we're going to do that is we are going to we're going to have to get the rigid body, which is already predefined. So rigid body is now equal to this component here, and that's something that Unity does for us. A couple of these are predefined, like rigid body and camera, so you don't have to search. You don't have to find the component. You can just say rigid body. It's been predefined. And what we're going to do is we're going to freeze our. We're going to make it so that we have constraints. That's what it's called. Here we are. And you can see that rigid body constraints is an enum. So it's got all of this stuff, right? And what we really want to do is we want to freeze all, except we don't want to freeze it on the x or the y axis. So how are we going to go about doing that? Well, here's the annoying thing about this. This is not a bit field. It is an enum that has been lined up to pretend it's a bit field. So we can't use any of the bit operators on it. Instead, we just use minus. Oh. Alright, so that should be pretty straightforward, right? Let's go ahead and hit play, and we'll just make sure that that works. Alright, so here we got these Tetris chunks, and you can see that it did not work because I froze the position but not the rotation. And did I just... I don't know whether I subtracted something wrong or whether freeze all is just positional. Let's go ahead and take a look. Okay, so freeze all did work, but the minus didn't work. I screwed up this part here. Not sure exactly what happened there. Hold on, let me figure it out. It looks like there was something slightly screwy in the way that it was handling the subtraction casting. So what we're going to do is we are going to combine these, like so. But we're also going to have to cast it to a rigid body constraint. Let's see whether this works. Oh, okay. So there's definitely something screwy going on here. I'm pretty sure that these are integers and not bitmaps. So I'm pretty sure that what we just need to keep casting into int and then back. But I don't like how this looks. If this doesn't work, it means that I've done something. I've made an assumption that's wrong somewhere along the line, which would be annoying. Nope, that worked. It was just a matter of it deciding that the casting to int and the order of operations is going to go in a different way when you're working with enums as opposed to integers. So I just cast everything to an integer, and then I did all the math out, and then I cast it back to a rigid body constraint. And the way this works is that freeze all is defined as something like 255, whereas freeze position x is defined as something like 1, and freeze position y is defined as something like 2 or 4. So it pretends that it's a bit field. I'm not a big fan of doing it this way, just because I find bit operations or byte operations a whole lot more easy to remember because of the way that they just naturally add and subtract without, you just turn them on and off. You turn each, zero, the 0th place, the first place, the second place, they each stand for one thing, and you turn them on and off. This does that as well, but it does it using integer math, which is not perfect, but it works. Alright, so now we've got the constraints working, but what we don't have is we don't have it trying to get back to its target position. So here in update, we're going to say if not flying solo, then return. And now if we are flying solo, then we want to get back to target pause. And we're going to just continually apply small amounts of force to try and get us back to our target position. There are a lot of ways to do this, and this is going to interact with our physics material considerably, so that's going to be a fun thing to work with in the next episode. And if you were planning to just write out physics entirely, you wouldn't have to worry about physics materials. But I'm actually going to use physics materials in here specifically to show you how to use physics materials, because it's not really very well covered in any of the tutorials. Alright, so we're trying to get back to the target pause. We're going to add a small amount of velocity towards our target position. So vector3 delta equals transform.position minus target pause. I hope that's not backwards. I might have it backwards. We'll find out. If it explodes, then I have it backwards. Rigid body dot velocity plus equals delta. Oh, you know what? This shouldn't be an update. This should be a fixed update. Fixed update gets called every physics event rather than every frame, and that'll give us a much smoother method here. So there we go. Now, delta time is always going to be the same in this fixed update function, so we could actually make this a magic number like 0.0002 or something, but for now this will work fine. So we should see a lot of slipping and sliding. The question is whether they're going to explode outwards or... Yeah, I've got it backwards. So we're going to pause that, or stop that, and just reverse these. So we still should see a considerable amount of slipping and sliding, and that's because we don't have any damping turned on. So I'm going to go ahead and turn on damping. Oh, actually, it seems to work pretty well. Obviously, it needs some tweaking. But the problem with it right now is primarily that the physics object is screwy. I mean, the physics material is screwy, and that's something we're going to deal with in the next episode. And you can see what I mean. All of these blocks are very sticky. They kind of get stuck to each other. And also, we have a problem where these things just go crazy. They don't have enough. They don't have enough drag. In fact, they don't have any drag. So we're going to go ahead and put in some drag and then call it a day. So here in rigid body, we'll just set it to 1, which means that it'll completely stop after 1 second. I believe that's what it means. Whatever it actually means mathematically speaking, the higher the drag, the faster things stop moving. Since we're applying a continuous velocity modifier, what that means is that our velocity modifier will be far stronger. But you can see that it's not working right, and that might be because 1 is just too strong. It could also be because this is too small. Let's go ahead and change both of those. And then in the next episode, I will teach you all about physics materials. Whoop, whoop, whoop. Okay, so that's too much velocity. Oh! So this was right. This needs to be a little bit higher. But we need to turn off gravity. That's what I've been forgetting. Alright, there we go. Now it should. Now we shouldn't have the same problems that we had before. We should have different problems. I thought I told you to not use gravity. I guess they're not. I guess they're just... Well, we'll have to deal with this next episode. There's obviously some screwy things going on, but as long as our physics material is sticky, I can't really tell who is to blame. Let's just make sure that these aren't using gravity. They aren't. Not sure why they are. Well, until next episode when we will make these bricks behave.